moving on to the second concept, which is the concept of threshold. In the context of dynamic concepts, a threshold refers to a critical point or value at which a system undergoes a significant qualitative change or transition in its behavior or state. It represents a boundary or tipping point beyond which the system exhibits a different pattern or behavior or property compared to its previous state. Now, thresholds can arise in various complex systems, and they are often associated with non-linear responses and feedback mechanisms. Crossing a threshold can lead to sudden shifts or phase transitions or even division in the system's behavior, resulting in new stable states or behaviors. These transitions can be triggered by changes in internal or external factors such as parameters, inputs, or environmental conditions, and may be reversible or even irreversible. So let's move directly to see an example in a simulation model in order to more clearly understand this concept. So the model we have here shows how a fire spreads in a forest that has trees. So the forest has a certain density of the trees. What you see in green are the trees, and what you see in black are just patches that do not have trees, which means that they cannot catch fire. So only green patches are the ones that can catch fire. So let's run the model to see how the fire is going to spread. So as you can see, the fire is only able to reach a certain distance through the forest because of the existence of the black patches, which are capable of blocking the spread of the fire. Now, if we increase the density of the trees to, let's say, 80% and run the model again, we will see that in this case, the fire is able to spread and to reach the most right edge of the forest. In this model, we are able to see that there is a certain threshold percentage in which the behavior of the spread of the fire changes. Below this percentage, the fire cannot reach the most right edge of the forest, while anything above this percentage, in that case, the fire will be able to reach the right edge of the forest. So after doing several tests with the model, we were able to see that this critical percentage or threshold percentage is around 59%. So let's see, for example, if we use a value which is close to 59%, such as 55, and we run the model. So as you can see, still in this case, the fire cannot reach the edge. Now, if we choose a value maybe a little bigger than 59%, like 63 for example, and we run, you will be able to see now that this fire reaches the edge. So this is the threshold point where the behavior of the system becomes completely different. So before this threshold point, the fire spread is limited, while after this threshold point, the fire spread will definitely go to the whole forest to reach the most right edge.